The next video in the Puzzle of Matter lecture series is on mixtures and pure substances. 3 learning targets in this video. The first of which we want to be able to differentiate between heterogeneous and homogeneous mixtures. In a heterogeneous mixture, that mixture does not have a uniform composition, and the substances, they remain distinct from each other. In other words, you can observe the different substances in the mixture. Here are some examples. Here's a picture of some granite. You can see the different substances in it. Here is a picture of oil and water. And then here is some sand in water. In a heterogeneous mixture, the substances exist in different regions of the mixture, oftentimes which you can see very clearly as you can in these 3 pictures. A homogeneous mixture, which is also called a solution, they're one and the same, has constant composition throughout, and the substances are no longer distinct, even though the mixture is composed of more than one substance, and even though those substances remain the identities that they are, you can't tell the difference between them looking at the mixture or even tasting it or smelling it. Every solution would contain at least one solute, which is the substance getting dissolved. And then every solution has a solvent. That is the substance that does the dissolving, or that dissolved the solute. Now, oftentimes we think about solution as putting a solid in water, but water does not have to be the solvent in a solution. Just some examples. Air, for example. Air is a mixture of all sorts of gases. The main component of our atmosphere is nitrogen. So we would consider nitrogen gas to be the solvent, and then all the other gases, oxygen, water vapor, methane, carbon dioxide, and any other gases in the atmosphere would all be solutes. A large class of solutions are known as alloys. These are solid solutions of metals. If you take a look at table 2.1 on page 23 of your text, it will give you several different examples of these solutes, of these alloys, excuse me. Gasoline would be another example. Gasoline is a solution that contains liquids, but none of those liquids are water. Gasoline is a mixture of all sorts of hydrocarbon liquids. Hydrocarbon meaning the liquid is composed of compounds made of only carbon and hydrogen, or mainly carbon and hydrogen. Now, if a solution is based on water and water is the solvent, we call it an aqueous solution. And you can see the root word, and the word aqueous comes from aqua, meaning water. For each of these substances or mixtures, I want you to identify them as heterogeneous mixtures or homogeneous mixtures. Ask yourself in each situation, can I distinguish between the components in the mixture? If you can, then it's heterogeneous. If you cannot, then it would be homogeneous. Gatorade. Gatorade would be a homogeneous mixture. When you look at Gatorade, you can't see the different parts. When you taste it, you can't taste the different components. It just has one taste. Salt water. That would also be homogeneous. If you look at salt water, you can't see the salt and the water particles separate from each other. When you taste it, you can't taste anything. You can't taste the salt separate from the water. You get the taste all together. Soil. So in other words, if you go out in your backyard, you dig up some dirt from your garden, would that be heterogeneous or homogeneous? I think most of us would agree it's heterogeneous. If you look at it very closely, you can see that some different components in it. Pizza. This could be any pizza: pepperoni pizza, cheese pizza, vegetable pizza. In any case, it would be heterogeneous. You can easily see the different components, and obviously you can taste them too. When you take a bite of pizza, you might taste a little cheese. You could also taste some sauce, some pepperoni, some crust. You get the different tastes, and you can distinguish them. Milk. This is probably a confusing one for many. Milk is actually a heterogeneous mixture. You might think, oh wait, when I look at milk, I can't see the different parts. And when I taste it, I really only get one taste. And so in that sense, you might say it's homogeneous. The reason why you can't really see the different parts is due to the cloudiness of milk. And if you let milk sit for very long past its expiration date, it'll actually start to separate into its components. and that is characteristic of heterogeneous mixtures. Homogeneous mixtures really do not do that. So now that we've differentiated between heterogeneous and homogeneous mixtures, we want to do the same with pure substances, and those two types of pure substances are called elements and compounds. An element is the simplest form of matter. It cannot be broken down into simpler substances. There are 118 known elements as of the recording of this video. Elements are thought of as being the building blocks of matter. Because our world is composed of millions of compounds, yet they only come from 118 elements. So they truly are the building blocks of our universe. 92 occur naturally on Earth, and less than half of these play much of a significant role in the chemistry of Earth. There's just not very much of a lot of the elements, so little of them, in fact, that they virtually have no impact on our living on Earth. We know these elements are organized on the periodic table with symbols. Every element has a 1 or 2 letter symbol that's associated with it that we can look up on the periodic table. Here are some pictures of some elements. This would be gold. This is diamond. This is a diamond which is made only of carbon, so that's the element carbon. And then here it looks like we have some lithium. Another type of pure substance or substance is known as a compound. Compounds are chemical combinations of 2 or more elements combined in a fixed ratio. What we mean by a fixed ratio is this. Let's consider water. If you look at a sample of water, it is always composed of 11.2% hydrogen and 88.8% oxygen. That's regardless of where we get the water, its source, or how much of it we have, its sample size. The properties of compounds are usually very different than the properties of the elements that make them up. An example of that is sodium chloride, or table salt. Sodium is a silvery white metal. It is so soft, in fact, that you can cut it with a butter knife, and you can see a picture of that here. A sample of sodium is being sliced up with just a butter knife. Sodium is also highly reactive with water. You place sodium in water, and you can see we get a very violent reaction here. Lots of light given off, heat as well. Chlorine is a greenish yellow gas at room temperature. Here we can see a picture of chlorine gas. And chlorine gas is also quite toxic to humans. If you breathe much of it in, you will get very sick, and it could lead to death potentially. However, when we combine them chemically, we get sodium chloride, which is just table salt. Obviously, sodium chloride, its color is different from either sodium or chlorine. Sodium chloride would not really be able to be cut with a butter knife. It's very brittle. So it does not react violently with water. In fact, it just dissolves in water. And salt is not toxic like chlorine, although it's not really very good for your health if you eat too much of it. But it is certainly has very different properties than either of the elements that make it up. Any compound can be represented by a chemical formula, which is simply a combination of chemical symbols and subscripts to show the composition. So for example, we have water, which is composed of 2 hydrogen atoms and 1 oxygen atom. The symbol for hydrogen is H, the symbol for oxygen is O, and there are 2 hydrogen atoms in a water molecule, so we have a subscript 2 next to the hydrogen. C12H22O11, that's table sugar or sucrose. MgOH2, that's magnesium hydroxide, or sometimes known as milk of magnesia if it's in a solution. H2SO4 is sulfuric acid or battery acid. And then CH3COOH, that is acetic acid. That is the acid that's in vinegar. We want to identify each as an element or a compound. Just ask yourself, for each of these, does it contain more than one element? And if it does, it has to be a compound. If it only is one element, then it's obviously an element. Copper. Well, copper we can find on the periodic table, so that's an element. Carbon dioxide. That would be a compound, obviously composed of carbon and oxygen. That makes it a compound. Potassium, that's also an element. Iodine, we can find that on the periodic table, so that's an element. Ethanol. Ethanol is not an element. In fact, it's composed of carbon, hydrogen, and oxygen. That makes it a compound. The last thing we want to be able to do is combine what we've learned here about mixtures and pure substances, and we want to be able to identify matter as a heterogeneous mixture, homogeneous mixture, element, or compound. So when you're asked to do this, you just want to ask yourself, is this matter, is it a mixture, or is it a substance? And remember that mixtures contain more than one substance. Pure substances have symbols or formulas. So in other words, if you can write a symbol or a formula for it, you know it's a pure substance. If it is a mixture, ask yourself, does it have uniform composition? If the answer is yes, and you cannot distinguish one substance from another, then it's homogeneous. If the answer is no, that means you can distinguish one substance from another. That makes it heterogeneous. If the sample is a substance, ask yourself, how many elements make it up? If it's one element, then it's an element. If it's two or more elements, then the sample must be a compound. So simply identify each as a heterogeneous mixture, homogeneous mixture, element, or compound. Caffeine, and here you're given the formula for caffeine. The fact that you're given a formula tells you that it's a pure substance, and we can see that it's made of more than one element, so that would make it a compound. Pepsi. Pepsi would be a homogeneous mixture. Obviously, there's many different substances that make Pepsi up. What makes it homogeneous is the fact that we cannot distinguish between those substances that are in the mixture. A 12-karat gold ring. This is a homogeneous mixture. Gold, unless it's pure gold, which would be 24 karat, gold jewelry is often a mixture because gold is so soft. It's mixed with other metals, but we can't distinguish the gold from the other elements just looking at the jewelry, or in this case the ring. So that makes it homogeneous. Carbon, that's an element. We can find it on the periodic table. Water, that would be a compound. We can write a formula for water, H2O. It's formed of more than one element, so that makes it a compound rather than an element. Dirt, heterogeneous. If you look at a sample of dirt, you can see the different components in it.